dude, so I just found the coolest shell trick. I had no idea this existed. I'm gonna give you a few examples of it, and then I'll explain to you how it actually works. To start with a really simple example here, okay? Say I wanted to download a file off of my GitHub, and I then wanted to edit that file, right? Normally, I would just go ahead and do wget, paste the link to my file, and then I would edit that file that had just downloaded into my home directory. So I'd have this file inside my home directory, go ahead and quit out of this. What I can do instead here, and let me make this big so you can actually see it. What I can do instead is I can do an arrow, I can do an open parentheses, I can do curl, paste my link, and now I have a temporary file that is actually residing inside my proc directory, which I'm going to get back to why it is. But this is a temporary writable file. I can go ahead, write to it, and now I can save this as whatever I want. You know, say I want to save this as new file, I can do so. Okay, so this is a really simple example of this. Let me show you a little bit more of a useful example. And to do that, I've got a couple of files. So say I've got a file, file 1, and a file, file 2 here. And file 1 is in order here, right? Like this is readable, it makes sense. File 2 is just file 1, but it is shuffled around. So all of the lines are out of order here, okay? And if I were to sort these files, they should actually sort out to the same file. Like if I sort file 1 and sort file 2, this I know logically should be the same. But say I need to test that, or say I'm trying to figure out if they really are the same, what I would normally do, I would do diff on those sorted files, and I would actually have temporary files that I had to write to, because if I just do diff on these files themselves, of course there's going to be a difference since they are, you know, in different orders. But instead of having to make temporary files here, what I can do instead, I can do diff, and then I can just do that trick that I was showing you, sort file 1, sort file 2. And now there should be no output on this. These should be the same file, because when they are sorted, they are actually the same file, because when I sort them, they're just in alphabetical order there. And to give you another example of this, say I actually wanted to replace every instance of the word rabbit here with a different word. Like say I wanted to replace all of the rabbit with like groundhog, okay? And say before I do that, I actually want to check and make sure that like everything that I'm going to replace is indeed what I want to be replacing. Normally you would write it out to a temporary file so that you didn't overwrite your file that you were concerned that you didn't want to like make mistakes on. What we can do instead here though, I can use diff again, I can do diff on file 1, so that's our original, and then what I can do sed and do my replacement here, so I can do rabbit, groundhog, and I'll do that case insensitively there, capital I, and then I will do that on file 1, close that out, and this is now going to be the difference between our original file and that potential sed statement that has not actually been performed on file 1 yet. File 1 right now is untouched, it's still the original, but there is what would happen if I ran that sed statement. So this alone is really, really useful. So let me explain to you how this actually works and what is happening here. So essentially what this is called process substitution. And what process substitution is doing is when I've got something inside these parentheses here, it's saying the input or the output of the command inside those parentheses is just going to appear as a file. It's going to essentially pretend that it's a file. And I can actually do this in reverse to previous, but let me actually explain to you why this is useful first. Obviously it's useful in that I can skip out on my temporary files, or I can have that like temporary file in my proc directory that's, you know, gonna get written to before having that file in my home directory, right? All of that makes sense, but the reason why this is useful in terms of performance, if you think about it, right, it is faster to just read alone as opposed to read and then write and then read again, right? It is faster to just read by itself as opposed to having to do reading and writing and reading again. So that actually is why this is better in terms of performance, and then just overall, it's generally going to be better to run things in parallel as opposed to, and running things concurrently, right, parallel processing, as opposed to just running all of your separate commands and like piping them into each other and that sort of thing. So this is really good for performance. Let me show you how this actually works in the reverse, because this is possible to do in reverse as well. And let me start with like kind of a party trick of a command. You're not going to expect the output on this. So ls-l, we all know what ls does, right? So say what I do is I do this process substitution in reverse of how I was doing it previously. Let me just send this to cat alone by itself, just cat there. we're gonna get our proc directory file again. I told you it was gonna come back. So proc is now back. What is actually happening here? So what we're saying with this command is we're saying, give me a temporary writable file. Give me this temporary proc thing here, this file, right? Give me this temporary file to, that when written to is actually gonna send data back to cat's standard in. And that probably doesn't make a ton of sense. So let me give you a better, real use case with this that you could actually use it. So you've got a program, right? And in that program, it's going to send you a bunch of messages, right? It's going to send you your info, your warnings, your errors. General programs do this, right? They have error messages. Say I want to keep an eye on all of the output that program is giving me, but I also want to log my errors at the same time. So what I can do here, I can take my program. My program in this case is literally called example. It's just a shell script that's going to give me a bunch of feedback on it as it runs. So example, we can take example, we can first of all just send it over to less, right? If we send it to less, I can just keep an eye on it as it runs. It's just going to be updating as it runs, right? But what I can also do, I can send my error over to an errors.txt file. So what I want to do is t here, and then I want to send this to errors.txt. Go ahead and run this, and I should be able to keep an eye on this shell script as it's running. So this is just messages the shell script is sending me. Okay, it errored, it's doing some more stuff, it gave me a warning here, it errored again. Okay, we get the idea. So now I was able to keep an eye on that, but I also have my errors logged over to errors.txt at the same time, which this is actually something that is like genuinely useful. And otherwise you would be having to do this in like some pipeline or some other like set of commands. We can just do this all in one simple command here to get both of these things accomplished at the same time. And let me give you another example here, okay? I've got a directory here called directory. Say what I want to do. I've got some servers that I want to back up to, right? And say I want to archive this directory, send it over to 2 different servers at the same time, and once that archive is on those servers, I want to unarchive it on those servers, right? And normally this would be like a bunch of commands, or it would be a pipeline. It would be something a little bit annoying and potentially not that complex, but it would be probably a little bit annoying to do. What we can do instead, we can go ahead and run our tar command to archive this directory, tar cf on this directory here. What I can then do, I can send this directly over to my server. So what I want to do, I want to use T here since I have 2 different servers. I'm going to send this SSH into Giraffe, which is actually just my laptop. So that's my first server here that I'm sending it to, right? And what I want to do on Giraffe, I want to unarchive this. So tar xf, and we'll unarchive it there, and also send it over to my other server. So SSH 192.168.1.7, I think it is, and then tar xf. If I could type tar xf dash over there, and I'm going to send all of this out to dev null, and if this works, we shouldn't have any output here. So this should go ahead, archive it, send it over to those servers, unarchive it there without the need for a temporary archive file on my system. There should be no archive of this directory here. We didn't need an archive of this directory because we're essentially using this SSH as this file that tar is going to see it as a file that it can write that archive to. And instead, it's just an SSH that we're sending it over to, right? So that is another like real life use case of this. And to just finally demonstrate it's something really important to you, which is the difference between this and piping, okay? I'm going to go back to file 1 and file 2 here. So cat file 1 and file 2, and just cat both of these so you can see what it looks like, right? It's just file 1 and file 2 concatenated together. Say I want to edit these in Vim, I would just like pipe these into Vim if I was just using a pipe there, right? And we don't have a file. This is a buffer that has this concatenated text in, but this is not a file that I can write to. If I wanted to write, I'd have to, make a new file name that I wrote to there. So instead, what we do with this process substitution here, I would just go ahead and do v and then open that up, cat file 1, file 2, and this is where we're going to get our temporary file in the proc directory. So this is an actual file that I can write to, and that is the key difference there between the piping versus the process substitution, right? Piping is just messing around with standard in and standard out, whereas process substitution is going to actually have this real temporary file here. So this cat command is going to appear as a file for Vim to read. So yeah, this is process substitution, and I found out about this yesterday. I don't know how I missed this when learning about Bash, because this feels like this is like a fundamental thing, but yeah, I just learned about this. So anyway, I hope you learned something too. I will see you next time. Peace.